net current will be 0 or entire force will be 0. So F is equals to my 8.1 cross 10 to the power minus 2 newtons. So my force is equals to 8.1 cross 10 to the power 2 newtons. Now you can just see that example number 4.7 for you. My two long and parallel straight wires and both are at point A and B. And I want to just say that 8 ampere and my another current is called as a 5 ampere. So I am using that I of A is equals to 8 amperes and I of B is equals to 5 amperes. I have a perpendicular distance which is given to me, that is called as 0.04 centimeter, means meter I am converting, and both are perpendicular at a distance or having length of the wire. So my length of the wire, you can just see that the length of the wire would be 10 centimeter, so that would be 0.1 meters. So you are aware that whenever two such type of current carrying wires you have, my formula is equals to mu 0 I1 I2L divided by 2 pi y is called as my perpendicular distance. I am putting all those data. 4 pi cross 10 to the power minus 7, 8 amperes, then 5 amperes. My length would be 0.1. I am putting 2 pi as it is, and my perpendicular distance is 0.04. 2 pi 2 za, then I have 8, that would be converted into terms of a 2, and then 5 and 2. So I can just get my all data of the force, that would be 2 cross 10 to the power minus 5 newtons. So these are the things you can just use whenever you are finding it out. Two parallel current carrying wires, it is the only formula for two current carrying wires, because in this chapter we don't have any other example or any other formula or any other case when two current carrying wires are parallel or placed at something distance. We have also discussed some of the special cases when what would be the force or magnetic field at a center or outside. So you are aware about those formulas, but this is the only simplest to simple type of example when you have two current carrying wires and both are parallelly placed, and perpendicular distance would be there. So these are the very ideal examples we have. Now after that we have another example, that is called as example number 4.8. In the example number 4.8 you can see that that is called as a number of turns is been mentioned, but very first word which is coming into your mind is called as it is a solenoid. It is a solenoid of 80 centimeter long, and you are aware that whenever solenoid is there, we have only simple formula B is equals to mu 0 Ni. Then we have solenoid is diameter, it is called as its radius would be also needed, and it is called as a current, that is called as 8 ampere. There are different layers are there, so number of layers are there and number of turns are there. So whenever I'm having such type of thing, I'm just using that capital N is equals to number of layers multiplied by turns. So I have a number of layers are 5 and number of turns are I have 400. So I have capital N, that is called as 2000. You are aware that N is equals to capital N by L, that is why I have 2000 divided by my length is called as a 0.8. So my number of turns per length is equals to 2000 divided by 0.8 number of turns per length. So you can just use that per meter, it is called as a meter inverse. So this is the very primitive conversion I have placed to find it out small n. My diameter is there, but it is of a no need, so I'm just using this formula B is equals to mu 0 Ni, where I can just use this formula B is equals to mu 0 capital N I divided by L. I have this value directly available to me. I'm putting that B is equals to 4 pi 10 to the power minus 7, that is called as 2000 divided by 0.8, and number of current or amount of current, that is why I have a magnetic field 8, and that would be 2 and 2 and 4, that would be 2.5 cross 10 to the power minus 2 Tesla. So this is how you can convert such type of example. Whenever you can have a solenoid or toroid, you are aware that only simple formula we have B is equals to mu 0 Ni, but be careful, they will give you that number of turns per length or the layers you have. So be careful, they are dealing with the capital N and you have to deal with the small n, which is called as the number of turns per length. Next one is called as our 4.9. You have been given that a square of a side means length of a 10 centimeter. Small n is equals to 10 centimeter. You can say that 0.1 meter. It is having number of tons only, they have mentioned that. So you have only number of tons, that is called as a 20 tons. Then you have a current I is equals to 12 amperes, and which is making an angle of 30 degrees. Magnetic field is given to you, B is equals to 0.80 teslas. So these are the primitive data available to you. You have to find it out what is the magnetic torque. You are aware about the torque formula. Tau is equals to, we have a formula BI sine theta, bina sine theta. For that we require our area. So right now I'm just using that it is a square loop, so its area would be L square. I have a 0.1 square and that is called as a meter square. So this is the area of mine. I am putting that all those data available to me, that is called as a 0.8 Tesla. My current, that is called as a 12 ampere. Number of tons are 20. My area is called as a 0.1 square, and my theta, which is called as a sine 30, it would be 1 by 2. So I'm using all those data, then I can have a 12, that is called as a 0.96 joule, or I can just use that data Newton into meter. So these are the very simple type of examples. Sometimes instead of a square coil, they will just give you that circular coil or maybe triangular or whichever area you have. Just go to its a formula. Instead of a, whenever you have a circular pi r square, or you can say that 1/2 height and base, whichever shape you have, area you have, rather than using the word shape, better follow that area. Then area, you can find it out and you can place its value over here, and that would be quite easy for you to calculate all those data available to you. So these are the very simple type of examples we have.